What does it mean to add a many-to-many relationship? It really means creating varying combinations of two types of objects. And it's not much different than working with one-to-many relationships. Quite often, adding a many-to-many means connecting two existing objects. But before we can do that, we'll need some artists and book covers in our database. Keep in mind that we don't know yet which books these covers are for, and we'll be sorting that out in the next module. So to get artists and covers into the database, I've defined some more seed data in the Pub Context class, where I've added 3 artists and 3 covers. Currently, they're not connected through any relationships. It's just a pool of artists and a bunch of covers that we know we need to assign. I've also created and run a new migration, which has put that data into the new Pub database tables for me. Given that we have this existing data, we could assign an existing cover to an existing artist, or an existing artist to an existing cover. But we're not creating new objects per se. Let's see that in action. This first method uses the find method to retrieve 2 artists and a cover. Then it adds the 2 artists to the cover's artists property and calls save changes. It's that easy. Now, here's the SQL sent to the database. Up top are the queries for the authors and cover. But what's interesting is what happened on save changes. EFCore sends a single command with 2 pairs of parameters that will insert the 2 new rows into the artist cover join table. And unlike the inserts we saw in the past, there's no generated primary key to worry about, and therefore there's no output clause in this statement. So those 2 artists are now tied to cover ID 1. Now, when we were working with books and authors, we had a foreign key property in the book class, so it was possible to connect a book and author by setting the book's author ID property. But Skip Navigations doesn't give us that capability. The IDs are inferred in the join entity known only to the data model and the database, but we don't have access to them in code. So with Skip Navigations, we have to work with the objects when we're connecting 2 ends. And remember that join table has a primary key that's composed of these 2 IDs, and that composition must be unique. So if I ran that same exact method again, it would cause an error in the database when we attempt to create that first row with the same value pair that now already exists in that table. What if we're creating a new cover and assigning it to an existing artist? In this case, we still need the artist in memory, so I'm using the find method to retrieve the artist, and I'm creating a new cover. I can either add the artist to the cover's artists collection, or I could go the other way and add the cover into the artist class. Honestly, there's no difference. It's a matter of your personal perspective and your personal choice. Or maybe even some standards set by your team so that the code is readable by everyone. Now, in this case, the context is tracking the artist already. But if I call detect changes after I add the artist to the new cover, the context is still not aware of the cover. So while adding the new cover to the covers collection seems like redundant code here, it's actually necessary. The change tracker is now aware of the cover, and it's in an added state, and it's created a new artist cover entity, which will be added as well. After calling save changes and looking at that SQL, you can see that EFCore knew to first insert the new cover so we could get back its ID. Then it sends a second command to insert the new artist cover row using the artist ID of the one we queried and the cover ID that the database generated for the new cover. We've seen EFCore take care in its order of operations when saving changes for graphs. And this is just another example of that. A third pattern would be if you were creating the artist and the cover at the same time. In our business model, it doesn't really make sense to do that, but there are surely other domains and scenarios where it makes perfect sense to do that. So let's use our model to see that pattern. Here I'm creating a new artist, Keir Talmadge. She lives in my town, so I thought it would be fun to add her in. And I'll create a new cover object, and because Keir also works at the local Audubon Center, I'll set the design ideas to We Like Birds. Now, again, I could add the artist to the cover's artist collection or vice versa. It really doesn't matter. And it doesn't matter which object I add to the context because they're both part of the same graph now. So I'm just choosing the artist's DB set. And when I call Save Changes, it should be no surprise that EF-Core first inserts the artist and the cover, then uses the newly generated IDs for both of those to insert a new artist cover row. Now in the database, we can start seeing these many-to-many relationships. For example, the cover with ID 1 has multiple artists, and the artist with ID 1 also has many covers. Now, with this data in the database, we can start learning about querying across many-to-many relationships. We've just combined some artists and book covers, and that means we can start querying across our many-to-many relationships. All of the lessons you learned when querying the one-to-many relationship between author and books also applies to many-to-many. When querying artists, you can include covers, and when querying covers, you can include artists. You can also use projections to query the related data, or explicit loading, or even lazy loading. I'll show you a few examples so you can also note what's happening in the database and what the results look like. But there's no need to repeat all of the variations that you've already learned. I'll start by querying for a single artist whose ID is 1 and include that artist's covers. The syntax should be familiar now. I'm using the artist DB set, calling include with a lambda expression pointing to the artist covers property, and then using first or default, passing in the predicate to look for the artist whose ID is 1. While the ling query is pretty simple, the SQL is a little more mind-boggling to look at. And keep in mind that it has to query the artists, then connect to the join table, and from there, connect to the covers table. So it's a combination of joins, and in the end, it'll return all the columns listed in the select at the top of the statement, which are columns from artist and columns from covers. And thank you, EF-Core, for not making me have to work this out myself. The resulting artist with cover graph is like one of the one-to-many graphs that we saw before. It's an artist object which has 2 covers in its covers property. And of course, I can go the other way, retrieving a cover and including its artists. Here's another method where this time I'm asking for all of the artists and including their covers, if they have any. EF-Core goes about the same query, but this time it's not filtering on the ID. And debugging the results, you can see again that it was able to connect the artists and their covers in memory when they're materialized. I'll show you one more variation, which is to just get the artists and use their covers as a filter. I'm not including the covers, but in the where predicate, I'm filtering on artists who have any covers. The SQL is a little simpler than before, but still more complicated than I would have expected, because I only would have expected the query to see if there are any rows in the join table. But for some reason, and believe me, I do trust the EF-Core team, so I know there's a good reason, it's still navigating through the join table into the covers table. But still the query isn't selecting any of the columns from the covers table, which does reduce the complexity of this query compared to what we saw before. And looking at the results, in this case, I only get artists because I didn't ask for the covers, but instead of 4 artists, I only get back the 3 that have covers in the database. Now that you've worked with some one-to-many and many-to-many graphs, there's an important attribute of these graphs that you need to be familiar with, and that's recursive or circular references with the queries, with the many-to-many queries that we've just been performing. I'm going to go back to one of these queries, retrieve all artists with their covers, to show you something else interesting. But understand that this is not specific to a many-to-many relationship. This also occurred with the one-to-many queries, but I wasn't ready to blow your mind quite yet. So again, the link query requested all of the artists and their covers, and the SQL did the same. But let's look at the results a little more closely. Here are the 4 artists, we saw them before, and I'll expand the first, and we can see that there are 2 covers in its covers collection. Now I'm going to expand one of those covers. Notice that it has 2 artists in its artists collection. And if I keep going, expanding one of those artists, it has 2 covers, and each of those covers have artists, and those artists have covers. I could do this all day if I was really bored, although I am never that bored, or at least until my computer crashes. So what's happening here? Don't worry, we do not have a billion artists and covers in memory. What you're seeing is a common problem in computing with graphs of data. It has nothing to do with EF Core or even with .NET. These objects all have pointers to each other, so they continue to relay the relationship every time they come upon it. So it's just showing us the same objects again, even if we've referenced them already. So don't be alarmed if you see this recursive data appearing. I still only have the number of objects that were returned from the database, and the change tracker is only tracking a single instance of each of those objects. This is only something like a mirror reflection. We can also take advantage of that recursion, and since we've only been looking at the results in the debugger, let's spit out some of the artist and cover details to the console, which is much easier on the eye. And I'm going to do this in 2 layers. First, I'll iterate through the artists, and each artist will be represented by the variable A. Then I'll write out their names. If they don't have any covers, I'll just write no covers. And if they do, then I'll write out the design ideas of the covers that they're working on. And here you can see that output, the 4 authors with any book covers they're working on. Now I've modified the part of this method. It's a little more complex, but it's going to be a lot more interesting. We'll output a list of collaborators for any cover that an artist is working on. So that means I'll print an artist's name, as I did before, and I'm capturing the artist's ID into a variable primary artist ID because I'm going to take advantage of that shortly. Then I'll look at all of the covers for that artist and then further into each one of those covers to see that recursive data that you saw in debug, all of the artists that are attached to the cover, except for the artists that I'm currently focused on. So my filter is where the artist ID of the covers artist is not equal to the ID of the artist in focus. And there could be no collaborators or 1 or even more. Then I build up a string called collaborators that will be a list of the names of any additional artists. And then to make it more readable, if there are any names in that collaborator string, I'll put that in parentheses. Otherwise, the string is in its original state, which is empty. Finally, I'll print out the design idea for each cover along with the collaborator string, which will either be empty or have a list of collaborators. Okay, let's run it. And this is really informative. So my first artist is Pablo Picasso. He has 2 designs to work on, and the first one, he's collaborating with Dee Bell. Then I'm listing Dee Bell, and the only cover she's working on is that same one where now we can see she's collaborating with Pablo Picasso. The other 2 authors aren't collaborating, so there's no extra information there. So that recursion in the graph is not necessarily an evil. It just is what it is, and you can take advantage of it if you want or ignore it. But there is one place where it bubbles up a lot and can cause problems, which is if you're serializing the data. And we see this a lot in ASP.NET Core, which serializes data results into JSON. Dealing with it is a well-known and common pattern in ASP.NET applications. So when we get to the web app later in this course, I will definitely show you how to avoid the problem of recursive data when your web application is calling EF Core queries.